He has been a past member of the RSGB Contest Committee and is currently a CQ Worldwide Contest Committee member. Thank you very much.
So antennas for an effective contestation. So it'll be HF focus, not VHF. And anyone that is a world or European contest record holder may actually be able to teach me things, but you will try and give a good précis. So this is what I was asked to talk about, and we'll see if we end up summarising all of HF antenna theory in about 40 minutes, so this could be fun. So obviously I did my homework. You go away, do some research, ask some other contesters what's going to be the answer, and this is what they came up with. So success guaranteed, absolutely nothing to worry about. So just put up 3 or 4 of these in your back garden and you'll be top of the tables and have all those nice trophies on the shelves. Some people thought that may not be applicable to everyone, especially say for a UK audience. So was there something a bit more simple that would still be effective? The plan B solution was a dipole. Unfortunately, it was in North Korea, so again, would be very good for getting big contest scores, but again, maybe not so practical. So some of you look towards the door, maybe think they want to go to the presentation next door. Yeah, don't worry, I will calm down and we'll sort things out. But it turns out that we've got plenty of time for questions. So no, more seriously. So when we're thinking about contest antennas, we need to think about the contests that we're going to try to enter. Are we considering all band events, commonly 10 meters through to 80 or maybe 160 meters as well, or are we going to have a single band focus? So with a single band you may be able to put more or bigger antennas up. You can dedicate more of your time and money to that, and I guess the most recent example has been in the post-contest chatter after, say, CQ Worldwide RITI. We saw ENG3 SEK doing well with a 40-meter 4-square. We saw TIM G4FJK with a 6-element for 10 meters and posting very good scores, but across an all-band effort that then most people have to compromise. Need to think if we're also operating single operator or multi-operator. So again, if there are multi transmitters going at once, or we might want to share antennas. Again, is this properly feasible and applicable for what we want to do? We're operating at home, or we're operating on a field day site where we may need to construct things quite quickly. How often are we contesting? Many may be contesting every weekend. There's always an event on, and so they'll be looking for a reliable antenna system. Many other entrants just prefer to operate in a handful of the more major contests each year, and maybe going then the extra mile for that, and with a lot of preparation and bigger antenna systems. And our expectations. So what do we want to do? We're just pleased that we're on air? Are we having fun, happy to be taking part and reasonably competitive? Are we trying to incrementally do better than last year, or are we really gunning for those leading UK, Europe or worldwide scores? Our resources, I think it's already been mentioned in at least one presentation today already. It's the space that we have, the budget that we have, and the time that we have to get everything ready. And later on, I'm not proud, we can do a show and tell, and you can see how I sometimes got it right and also got it wrong later on. So I thought we'd look at, say, several different HF contest types, and then also we'll work through the different individual bands to look at different antennas that are commonly used and are used to do well. So for the HF sort of intra-UK contests, I'm sure you'll be aware that there are many, mostly sort of UK-centric weekday contests on 80 meters. And I think if you add up between the RSGB and UK EI events, there's 41 of them. So certainly you can be kept very busy. And traditionally here, say the common antennas used and the winning antenna used are the variants of course, say the wire dipole, doublets, Wyndhams, and other wires of that type. So we know for 80 meters that height, say, shouldn't be maybe a significant factor to making any contacts at all. Excuse me. As we know with NVIS and some very low antennas, you can still make many contacts. But looking at the results tables, as at the very top of the tables, the antennas generally sort of above 40 and commonly above 60 feet, and whereas at the bottom of the table, they are sort of much lower. But it's also interesting to look at the types of antennas. Again, at the bottom of the table, we've got antennas for 40 meters. There's more end-feds, that there are verticals in here as well. If you do struggle with space for 80 meters at home, as many of us do, so again, when we're looking at, say, shortening antennas, certainly bent antennas for 80, so with the ends of the dipole legs bent, won't give a significant performance degradation. And again, if you're having trouble horizontally, then do consider the vertical plane as well, with an inverted L or a loop. So if you've only got so many feet horizontally, see if you can bend it around the rest of the garden with 10 feet, 20 feet up or down at either end. Okay, looking at this further, we can do a nice scatter plot of a random 80-meter club championship of height versus score, not looking at any particular subset of categories and just the overall number of contacts that were made. So we can see here that there's a group at the top, maybe with their antennas at 60 feet plus. There's a second group I'm highlighting, maybe between 20 and 35 feet. And also, so we've got a group at the bottom with the ground-mounted verticals. So also we can see here that maybe the top 10 or so entrants have all got antennas above 60 feet. It's not automatic that you need to have an antenna at 60 feet to win. We need to consider that the entrants who have been motivated enough or have worked or moved house or put up at a remote site so that they can put up an antenna at 60 feet, they are then, say, more likely to be motivated and have the experience to do well. And also then likewise for this middle group here that is more towards the bottom end of the table, you can still be, I think, just within the top 12 or top 11 of the entrants overall, even with a dipole that was at 23 feet. So height is not necessarily a barrier to doing very well in these events. Also then, just picking out, say, the three at the bottom at 0 feet. So I think these are verticals rather than antennas that had fallen down. And you can still, say, do very well. You can still make, say, 50 to 100 contacts. But in terms of, say, getting a winning score or being in that top third or top a quarter, maybe a vertical isn't the way to go. So just looking back at, say, some of the basics, I'm sure we're all aware of this. So the theoretical view of the wire antennas, the center height is the most important, where we have the maximum current, maximum radiation. So a center support is often ideal. Practically, a lot of the time that we're dealing with something like this, we'll be using our house as a support. And again, how ambitious or how brave have we been to get that end high? Have we just put it up where we can on a nearby step ladder, or have we put up, say, a little stub mast on some T&K brackets just to get the end up an extra 10 or 15 feet? It can make a difference. Likewise, lots of us using trees. How ambitious have we been to get our wire into the tree? And there's various methods of getting those wires into the trees. And again, so say for those where we do, you don't have that horizontal space, you can let the ends drag down. And then number 3, of course, that center height. And again, if you do have an extra pole, if you're lucky enough to have a tower, or there's a convenient tree on your property, you can get some good center feed point height there. Cool. So quick photo from the archives. So showing how some things that you may not have expected to make a difference can do. So this is a sideband field day years ago. It's one of those motorway lighting towers with a fiberglass pole on top. We were, not very generously allocated a very small patch of the park to operate from, and we hadn't realised that we might be able to use that end lighting tower as a support. So the angle in the inverted V is quite sharp. We noticed when the results come out, we were absolutely trounced by our friends at Worthing District, who were using the 2 supports allowed with the rules at that time, and much more of a flat top antenna. Now, there's many things we don't know. They may have had a far better takeoff, as it may appear here. They may have had a far better strategy and operators, all possible. But just when we plot the the inverted V with the sharp angle against a relatively flat top dipole, we could see from the predicted radiation plots in MMANA that it did make quite a significant impact. So something that we didn't think about at the time, but we did think about afterwards. Next contest type, so European-centric. So there's lots and lots of these, so you could work perhaps all of Europe or maybe a particular organising country or area. For example, Scandinavian Activity Contest, Polish DX, worked all Germany. So for these contacts on the HF bands, it's going to be a high takeoff angle. If we do have a simpler lower antenna between 7 meters, 12 meters, that's going to be, say, very competitive. You can do well with a multiband wire. You can do well with zero gain antennas. So the thought here is that maybe if you are relatively fixed with your antenna type, then maybe you can pick your contest compared with your antennas as much as the other way around. As I keep mentioning heights of antennas, if there's any vertical users in the audience, they may think feeling left out. So to redress that, something I came across on Facebook just while I was putting this together. What are the opinions on the best HF vertical antenna? 12 answers, and of course 12 different answers, everyone with their own antenna that they're very pleased with. It's all a subjective opinion, but also the question itself says, what is best HF? What, on 10 meters, on 80, to Europe, to the States? It can't be best at everything, or if it can be, I certainly want to buy one. So for vertical antennas, I think I generally put them into, say, two main camps. There's a lot of the popular multi-band verticals that you can buy with traps or coils, allowing you to get active on many of the HF bands, which are fantastic. There's also then maybe a different camp where we have single band verticals, more largely, say, home constructed. We can do this ourselves with fiberglass poles and wires, with more of a focus on the low bands. And that there's far more detail than we've got time for today to go into phasing those antennas and turning them into a 4-square for directivity, or with 8, 9, or 10 antennas. And really doing that is, to say, the primary and the most popular way of getting, say, directivity and gain on the very low bands. It's often argued that verticals can be space-saving antennas, and in terms of their physical structure, yes, they only go straight up, but considering that many of them will be on the ground and with a sort of low takeoff angle, you can end up with sort of very disappointing, or perhaps quite disappointing results, especially if you have buildings, houses next to you. So my personal experience of that is that, yeah, I've had one of these popular verticals, but I always found it much worse into Europe, where I was making most of my contacts, compared with a low multi-band dipole. Radials, we can never have too many radials, and again, either a couple of elevated tune radials, which again may unfortunately just be at head height and disappointing for family members, versus lots on the ground. So certainly, if there's no nearby obstructions, verticals can and do work well. And again, so if you're wanting to put up a quarter wave for 40 meters or 80 meters or lower, if you cannot get everything in a single vertical, it's too high. You can then come out again horizontally with an inverted L, or consider base loading. And there's a whole extra lecture we could do on ground effects and the benefits of that, and how much of chalk or clay will make a difference. But we'll have to skip over that for today. No. Hello. It's not going on. Where is my presentation go? Help. Oh, sorry, we're okay. It's never done that before. Okay, on to a DX contest. So here, more or all of our contacts are expected to be with other continents. So this is now the real game changer. So more of our contacts need to be with a lower takeoff angle. We need to have greater antenna height. There's more likely to be extra volume of entrance. There's going to be a lot more competition from the big stations. So again, if we want to be effective, our antenna system needs to be keeping up with that. So essentially, more gain needed and better directivity. And depending on our mode as well, to say, I think it's often said that for a competitive station to do well on sideband on SSB, there are greater requirements than for CW, and again, then less for the FT modes and their contests. Okay, so where is the activity? Where are the populated areas? So for a great circle map populated on the UK, in an international contest, the vast majority of our contacts are going to be within these relatively narrow arcs. So Europe, then going out into Near Asia and North America. So with apologies to our friends in Scandinavia, Portugal and Spain, this is going to be where the majority of the contacts will be made. Not forgetting, of course, the very high amateur population that's in Japan, and whilst we certainly know if you go to another part of the world, they'll be there, or you can reach tons and tons of them on FT8. I think still at this part of the sunspot cycle, or with my antennas, I'm not getting enough or many SSB or CWJA pileups. So the purpose of pointing all that was if you do have a multi-op station or you're operating to radio and have multiple antennas, if you're able, maybe more likely in a field day scenario, you can line your antennas broadly north to south. Less often you'll be beaming through each other, and then you'll be helping yourself with any interstation interference issues. And again, if we can get our LF dipoles high enough, they'll also then be starting to show that directivity as well. We may also then be toying with in-band antennas. So if we're operating on 80 meters and transmitting there, having another receiver and an antenna receiving on the same band at the same time. So if you can get your antenna far away, or maybe if you're transmitting on a dipole, then consider a vertical as your extra antenna. With some luck, you can still receive in-band and not blow up your receivers. Okay, hopping on. So let's try and look at some more quantified evidence. So this is the RSGB DX contest results from last year. So don't worry, I know it's this year's contest just a week or so ago. So as we look at the results here, we can see that at the very top of the table, a beam at 18 meters plus is commonplace. However, you don't have to go down too far before we see places 6, 9 and 10, which I think was it Bryn, Stewart and Terry, are all using, say, just dipoles or loops. So you can still be in a top 10 position without using a Yagi. And indeed, if you go through all 133 entrants, as I did for you, 90 of them weren't using Yagis or beam antennas at all. So you can still be, say, very competitive, even if you don't have gain antennas. And the average antenna height was 14 meters. Another place we can go to see what is the benchmark is 3830scores.com. Don't know how many of you use this regularly. So after most HF contests, entrants will put in their claimed scores, some details about how they found conditions, and also then quite commonly list their working conditions. So this is great. You can just browse up and down, see who has had maybe a score nearer to your claimed score, and then see what sort of antennas were they running. And again, that will help you find out maybe to be in the running or in the pack, do you need to do more. And additionally, of course, QRZ.com, I'm sure everyone's aware of. Again, people are very good at putting in their biographies and sharing details of their stations, which can give lots of inspiration. Okay, so we've talked about the what. I think now we need to talk about the where. So location, 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 very important. If any of you are not aware, this is Kirsty and Phil from the Channel 4 TV program, helping to find would-be home buyers find a suitable place for them to live. It's mostly in the cities, so for us, I think we should hop over to BBC with Escape to the Country, which is far more appropriate for contesters, where commonly couples are shown a converted, a barn conversion, and they go, wow, look at the vaulted ceiling, and they never ask how much it's going to cost to heat in the winter. But for our purposes, I'm sure we're always there thinking what they could do with that nice garden space. So before I go off on a complete tangent, so yeah, local terrain, our takeoff, the horizon will influence our antenna performance. or we may be able to have an antenna at a lower height and get a similar to performance than at another location. So for this, we can commonly use, say, different software packages. So I've been playing with HFTA by Dean, with some software that came with the ARRL antenna book. So here we've got an output of the program. So we can see on the left-hand side we've got gain, and that is then gain relative or with respect to the takeoff angle of particular antennas. So you can change the nominal, say, size of a Yagi antenna, and you can change different locations as well. You need to import, say, topographical data into it. So what we can see here with our red antenna, so it's got, say, perhaps the best gain at particular takeoff angles, say between, let's say, 8 and 14 degrees. The pink bar chart at the bottom, that is the statistical likelihood of signals coming from, so in this case, to my receiver in G from the US. If it was in Europe, the takeoff angle would be higher, and if we're trying to do well in the Oceania DX contest, it would be a lot lower. So depending on our wanted contest, we can then, say, look at different heights, different antenna types, and work out what would be best. With the software, we can also look at our terrain profile. So at my house, both to the north and the south, I have what we could call an annoying hill. And it's certainly put paid to my huge VHF ambitions, but for HF, we get on and do with it. But also you can look around and see what some of your peers were doing as well. So relatively local to me, Tim, M0BEW, has a much larger annoying hill in the way. And having spoken with Tim, he was happy for me to share this. And he says that, yes, he can certainly detect that the hill is there, so doing other comparisons, and it's, say, several dBs down affecting him in a particular direction. But he knows, or his take on it is that now he's changing his operating style, that he knows that he's going to come onto a band slightly later, or maybe letting that North American opening become more established before he makes a move, maybe from swinging around from Europe. But whatever, even with that hill in the way, he normally does much better than I do. So if you are in a similar situation, don't lose hope. I am happy though, and yep, this was actually a factor in buying the new house. Yep, but my wife was happy with this. I've got a relatively good takeoff to Europe with nice sloping ground to Europe and also to North America. So that means even with some fairly scrappy antennas, I can occasionally do quite well. And another website to give a shout out to is Hey What's That? So you don't need to download and import any topographical information as we did with HFTA. You can just go online, pick your location, and then you can see in terms there so what your takeoff is like. Or also, you could just then have put a camera on top of your mast if you don't have a drone to fly around with. So I just put a Raspberry Pi on the top of my mast and did some nice panoramic photos. But if any of you do try this and you've got a mast like this, do remember to make sure that the anti-telescope catch is in the right position. Otherwise, you'll see that the mast telescopes out and pile drives the Raspberry Pi into the ground. Anyway, so we wanted to get something like this. This isn't my house, this is somewhere in Scandinavia. So again, we're coming back to that point, essentially with the nice Yagi looking towards the horizon. Is this what we want, to be as high as possible, to be effective? And then this photo also then showed me something else. Practicing this talk, I've looked at this dozens of times, but then it's only been very recently I've spotted that where the coax seems to go into the balun, that does look like a non-weatherproofed RF connector. So I hope it's meant to be like that, because your antenna is only as good as its weakest link. So maybe it doesn't always need to be so high. So again, coming back to MMANA, so we know, and reading the first chapter of my ARRL antenna book, we could consider RF from an isotropic radiator as being like a balloon. If we do want to, say, get any gain or with ground effects, then we're going to start to be squeezing that balloon, it'll go out in some directions and it'll be coming in other directions where we've squeezed it. So with our antenna here at antenna height of 10 meters, so we know we have a lobe, we have a takeoff at a particular angle. As we start to raise the antenna, the elevation can come down, which may be good for our DX contacts. But then as we get to a certain point, we're going to start to see that nulls may be in some useful directions do start to have an impact, and we need to be wary of that. And of course, as frequency also has a big impact as well, what may be great at 20 meters is going to be, say, really poor at 10 meters. So again, if there's the opportunity there to have different antennas at different heights, or maybe antennas that we can switch between easily, this is where we're perhaps likely to maximize the amount of contacts that we could have. So again, do remember this for fan dipoles and multiband antennas. Okay, moving on to Yagis. So commonly on the HF bands 10 through 20, we'll be using Yagis to increase our gain, both on transmit and receive. And our trade-off factors here, it's largely our support mechanism, our pole, our mast, our tower, how much weight can it accommodate, or what is going to be the wind loading placed on our antenna, and that is then usually, say, proportional to the amount of gain that we'll be getting from that antenna. Back when I were a lad, that was it, I'm not that old really, if you said to me what's an HF tribander, it always seemed to have, say, 2 or 3 elements and traps, whereas the most prevalent design today is for an interlaced set of monobanders without any traps. Need to consider how many elements per band, and as a rough figure, so this will change from design to design. As we add more elements, we'll get more gain, a few dB tailing off. But does this make a difference? How do we quantify that in real life? I guess we can say we could look at, say, the reverse beacon network if we're operating CW, or on FT8. It's even easier for all of us to do that today. So those neg 23, neg 24 stations that we're just about hearing on FT8, if we had one less element on our Yagi, it may not be there. And again, if we added one more element and we had more directivity, yeah, who knows what's out there that we're not currently hearing. And also look at the contest stations with continual investment. So to say the big multi-multis have a great set of stacks already, but periodically will take them all down and put them something back up with only a fraction of a dB improvement, because that's what it takes and that's what they want to do. Other options, and I didn't want to leave anybody out, again, we've got the motorized and variable geometry antennas, the step IRs, ultra beams, so giving monoband performance. Don't tend to see too many used for contests, maybe because of that time needed to change bands, if you're going to be hopping more frequently as a contester maybe than as a DXer. Fewer elements, so that'll maybe affect the wind loading positively, although it depends with the motors as well. And there's a whole debate over weight, longevity, and cost, but certainly it's something that some people consider. Wire beams, such as the hex beam and spider beam, very, very popular, low weight, and we think for the hex beam only is a very minor performance compromise through bending the elements. And quads, I was going to say quite rare, but literally 10 minutes before the talk, I think it was Keith said he had a quad, so crikey, we can't miss anybody out. And again, there are folks that will really say that quads are fantastic antennas, but being a 3-dimensional structure, again, there will be extra time then needed to look after them. And log periodic antennas, again, fell out of favor, but with more band-optimized versions these days, so they're coming more in vogue, but maybe, again, more for DXers that want performance across 5 bands, whereas the contesters were only worried about 20, 15, and 10. So essentially, if we can get full-sized antennas or larger-sized antennas, then that'll be better for performance. And at this point, I thought I could do a nice big table. We could look at all the antennas, popular ones. We could look at weight, wind loading, gain. But there were too many antennas. I felt that perhaps I shouldn't really be trusting all of those gain figures. and lots of the manufacturers, they didn't really list all of the common elements that we wanted to look at. So instead, I think perhaps we'll just look at and highlight some factors that you could do yourself if you're researching or in the market for new Yagis. Obviously, antenna designs have changed over time. There's a lot more, say, software modeling available today. I think we should also be aware that some manufacturers may just be borrowing designs, so that may be another factor as well. And do research the whole marketplace. There are some great, fantastic UK manufacturers of antennas out there, and also from the main UK dealers, have relationships with several European stockists, but there are also other stockists in Europe that maybe you could go to directly. I think like Momo Beam and antennas, amplifiers. So there is actually a lot of choice out there. So do make sure you research the whole market. I've mentioned the gain figures. Again, also perhaps something that might be overlooked, to just make sure that however you attach the beam to the mast, that is going to be something that would work for you, for your situation, and also it's going to be simple. And also, say for the matching to your feeder as well, is that something that looks robust and isn't going to fail just in 2 or 3 years' time in the middle of your favourite contest. And even some, perhaps you might think, really minor aspects, such as what are the booms made of? So if you have a square boom, it's easier to attach the antennas, but that then will mean that the boom is slightly heavier and also will give slightly higher wind loading. And are you a true blue contester, or are you a bit of a DXer on the side? You need to say, do I want those 17 metre and 12 metre elements as well, or am I going to dispense with those, and then I can have more elements for 10, 15 and 20 where we want it. And depending on where you do your shopping, again, cost and shipping, customer support and reputation for your choices. So, I'm trying not to call out any specific manufacturers as being good or bad, because especially with being recorded and streaming, I may get lynched later on. 40. So Yagis are rarer in the UK on 40. I think the Cushcraft 204, 402 CD or XM240 as it now is, I think was the most popular. There's a couple of perhaps interlaced Yagi antennas, including 40, but they're starting to get very, very heavy. So I think far more popular here are, say, the shortened rotatable dipoles, several commercial options, or also you can make your own sort of DIY fiberglass pole solution as well. So some decision points here, again, depending on how high you can elevate from your HF Yagi, if you need to use the same support. You don't want any interaction with 15 meters. So again, you may be forced, or you may prefer to then put your antenna at 90 degrees, but that makes it difficult when you're luffing over the mast, and also then you'll be rotating your antennas a lot more. And if you have a wire dipole, again, commonly wire dipoles are strung underneath the rotator cage, but again with a bit of ingenuity. If you did have a large stub pole above and either some mechanism that can rotate or just some string or wire and enough slack in the wire antenna, you could then get your LF antennas above your Yagi. And again, if that is, say, an easy 10 or 15 feet an advantage on 40 and also 80, that can have a big advantage. So everything's a compromise. So this is a diagram from Tom M6BT, who founded Force 12 Antennas. And in, I think, 2000 or 2002 QST, he got a nice article on the DX. He was working using a light bulb. He did worked all continents using a light bulb, and he was entering contests using a light bulb. So in essence, he was showing that everything works. But as you go up, as you improve your antenna system, then you'll struggle less in the pile-ups, you'll hear more, you'll work more, you'll have more fun. So that's then our curve of ambition versus performance. I'd like to add like an extra element of that, is that then also as a trade-off for, is it going to cause problems for your family or your neighbours? How often is it likely to fail, or how much money and time and expense is it going to need then to maintain them? So you need to choose where you are on that curve. And finally, if you're feeding with feeder as well, don't forget to do the sums. Consider your overall link budget. So do you have a target? I'm happy to lose or no more than 1 dB or 2 dB. And so beware of the compromises there. So I guess the choice is to say if you wanted to improve your antenna system by 1 dB, is it going to be easier to improve it at the Yagi? I need then to buy a bigger Yagi with an extra element, and maybe that's too heavy for my tower, or can I just run some better coax, and then essentially you'll have a similar performance. Right then, antennas at G0 MTN. So about 10 years ago I moved house. So starting afresh. So this was my 2 radio operating position at the time. So there at the kitchen sink, looking out onto the garden and dreaming. So it's all serious. So there's a whole other presentation we can do all about the 3 or 4 years I had having fun with planning permission, councillors, MPs, secretaries of state, because my plan was that this time, finally, I wanted to do it properly. We'll need a lattice tower. I'd like 3 elements on 20. I'd like a rotatable dipole for 40, please. After an intervening period where it was determined I could have nothing at all, we did eventually get a compromise solution like so. And this was from my diagram to explain how it would all be light and stealthy to the planners. And I think actually that's here. And that's Flossie, and that's the antenna that we've got outside today. So whilst we're sorting that out, we had the antenna in the tree evolution, which is de minimis in planning terminology, which means that essentially you can do what you wish with your wires. So again, it was going to be a sturdy center support for inverted Vs. It was stealthy. As it was an oak tree, as compared with a nice fir, I did have this complexity trade-off, as I couldn't get the antenna high in the tree, but essentially was going for one of the lower branches and limbs, and started off with a doublet, which was great, twin feeder, remote auto ATU, except the ATU was meant to have all these memories, and it would remember where you've last been on that band and tune. And it didn't. And then the twin feeder kept breaking. And I had sort of too much frustration with the doublet. And there was the power limitations on the auto ATU. So eventually I swapped out to a couple of fan dipoles. I have previously made lots of dipoles, lots of fan dipoles. But for so many bands, I did go commercial. And you'll struggle to see them. But yet those are the 2 center points, the 2 baluns. And the elements come off. I think the only changes I've made is that I wrapped the centers on all of the perspex spreaders in black electrical tape, and it's now virtually invisible, which is good. Then, hurrah, we had success with planning permission, so we then decided on a spider beam Yagi, which was lightweight, low profile, but still gave good performance with, say, at least 3 elements on the HF bands. And I could also then add their 40-meter integrated dipole as well. So I thought, this is looking great. Putting it together, it was more like sailing or sewing than what I was traditionally used to, but it was fine. I also, as then part of my stealthy antenna works, put it on a tilt plate. And there it was. It could sit there, so say, below the hedge, below the trees, and then just pop up for contests. And it was glorious. It worked really well indeed. The problem was this, and I knew this was going to happen. I'd used my Pythagoras. I'd done my calculations beforehand and knew exactly how high a platform I needed to get to do the tilt over. What I'd not bargained for was how much I don't like ladders, and also in the middle of the winter contest season, how marshy my antenna gets. And in health and safety parlance, there were a couple of what they would call near misses. So over time, I found that I got this lovely antenna, but I just wasn't using it because I didn't feel happy enough to go and play for a few hours. I also wanted to make a broadband 80-meter dipole. I operate sideband and CW. So we start, because I wanted to operate 2 radio, and we need to have resonant antennas, mostly because of a traumatic experience a long time ago where I was operating at a field day station and the bandpass filter literally went up in smoke before my eyes. It traumatized me somewhat. So we tried a broadband antenna with just several wires to make the antenna element seem very wide, so effectively giving it a high bandwidth. Didn't work. Tried a CW length dipole, sideband length dipole together. Didn't work. And eventually David G3YYD showed me how he had made his dipole. So I did put the elements very close together, awful lot of soaring. But eventually on this push-up mast that again needed to be stealthy, I just didn't have the strength to put it up and in the rain, and I was all fairly miserable with that. So that unfortunately got abandoned. So if you have a permanent setup, it would be great, but for me, it didn't work. And then the inverted L I've tried as well. So yeah, repurposed the pole there. It goes up and down. Use my daughter's trampoline when she's not using that, and a fishing pole just to get some height at the other end. And then I do waterproof this. And it's been really interesting that you add hundreds more meters of radials. I think I've now got about 1,000 meters down there. You can see that the resonance of the inverted L changes. So the SWR goes from good, and it's now not good, but the books tell me that it's actually then more efficient, and I just then need to be sorting out more capacitance and inductance. But yeah, that's been a fun experiment. And because my neighbours have over 200 LED lights in their house, thanks neighbours, I'm also then investigating loops and also beverages as well, as I think my friends in Norfolk, Andy M0NKR, is always kind enough to tell me when I'm accidentally transmitting all over the VK on top band that everybody else wanted to work. So I do know that there are still things to do. So as I know we've only got a couple of minutes left according to my kitchen timer, just wrapping up. So I went with a smaller Optibeam in the end. Other choices are available, but because it's very lightweight and it allows me to do the tilting mechanism effectively at ground level, this has been great. And even though I'm a hypocrite, I've not managed to get my dipoles above the Yagi with the mast, and also the other dipoles in the tree, providing that diversity we talked about later. If I've picked my category correctly, maybe not going in with the high power boys, maybe world fifth out of almost 900 wasn't bad from an effort just with this a couple of weeks ago. So overall then, to wrap up, the subjective order of preference. So I guess where we came in right at the start, those stacks of monobanders would be really ideal for what we want. And then we can go down in terms of effectiveness for what we're perhaps able to use or likely to use. Do want to call out that, of course, a well-placed wire dipole or vertical in the right location is certainly going to outperform a low beam. And indeed also a smaller, higher beam may also outperform a larger antenna if you're not able to get that up to a particular height. And as I found, yeah, any second switched antenna will be useful. So that's about it. So I think everything is a compromise. Every antenna will work. Everyone has a particular favorite or well-working antenna for their location. So just for your use case in the contests, consider what effective means for you. Do you want something that's easy to put up in a portable environment? Do you want something that's going to work every weekend? Or something that you, your family or your neighbours will allow you to get away with once every so often for a bigger contest? So look at what your other entrants and competitors are doing. Use the tools, software and online to help make those choices. So be ambitious, certainly, but also realise limitations to avoid any frustration. And of course, any antenna, maybe not that light bulb, is better than no antenna or no antenna at all. So with 44.5 minutes done, I'll thank you for your attention. I hope there's been at least something to take away to think about for the future. And if there's any questions, if we've got time for them, I'll be happy to have a go. So thanks for your attention.
Are there any questions? It helps if I use the microphone. Oh, there's one over this way.
Hi, I'm Mike, G4IZZ and M4N. Have you ever tried, maybe you just haven't wanted to, but wire antenna and the effects of NVIS for local inter-G contests?
So the doublet that I didn't get on with and fell down, I've put it back up. I found somewhere else in the garden, and it's only about 15 to 20 feet up, because the dipole in the tree for 80 metres, it's only narrow. I've got that down at the CW end, so I didn't have anything for 80 sideband. So yeah, I've been using the doublet and tried it on 60 metres, and it was working still great to ZL. And also in a UKEI 80 metres, I tried it, and it was working. It was working fine. So yeah, even if it's low, it's working. And that's what I've got currently, and I'd use that, but I still think, yeah, if we could get height, I may do better, but certainly at the moment, I'm using a low antenna, and it's still working well. Oh.
Hello. Sorry, I don't want to hog this, but just quickly, you know, I've read stuff about NVIS, particularly in America, and there's guys running antennas at 6 feet off the ground, and I completely agree with what you're saying. I'd love to get my antenna up at 60 feet. I've got a doublet. It's at 30 feet, and I sort of do okay, but you don't know what you're missing. But I do sometimes wonder, well, maybe I should play about bringing it down even lower to see if any of this is, if this NVIS stuff is true.
It's a good experiment, yeah. And there's lots of events, so you could say, and tonight I'm going to try 6 feet, and then next month try it at 15 and see what the difference is. Yeah. Super, thank you.
Are there any more questions? No? With that, so thank you very much for a very interesting talk, and if we can show our appreciation.